welcome to watching this video. In this video, I'll talk about transformer winding resistance, how you calculate it for Y and delta. So let's look at the sketch to the right. So we have a Y winding. So in this case, I'll talk about Y windings. So you have a winding, and it has a resistance per phase. It's called RA. And you have another winding. It has a per phase resistance B. And we have another winding. It has a per phase resistance called RC. So RA, RB, and RC are phase or winding resistances. So if I want the phase-to-phase resistance, like RAB, so basically I'm just connecting these two in series. So that's really what I'm doing here. Let's see if we have a highlighter. So RAB, I'm just putting this winding and this winding in series. So it's just the sum of those two. So RAB is equal to line-to-line resistance, which is equal to just the sum of the phase resistances. So this is more of a general equation, but if RA is equal to RB, which is the case for transformers, they are designed symmetrically, so then RAB is just 2 times RA or 2 times RB. So because all I'm doing really is just summing these two. So they are in series. And the same thing for RAC or RBC. So let's do a quick example. So a 3-phase transformer winding with winding resistance 3 ohms. So the winding resistance is the per phase resistance. So the phase-to-phase resistance is just 2 times 3, which is 6 ohms. So now let's talk about winding resistance and delta connection. So again, let's look at the sketch to the right. So it's a delta. So you can see it's closed. So let's get a highlighter. So now R1, R2, R3 are phase or winding resistances. So you have R1, R2, and R3 are just winding resistances. Now I want to calculate line-to-line resistance, which means from here to here. The problem here, all these are connected, so then there is no open. That's not like the Y connection where you have an open. So in this case, it's this winding in parallel with the sum of these two. Let me just get the laser pointer back. Okay. So RAB is equal to the line-to-line resistance, which is R1 and parallel with the sum of these two, R2 and R3. And if R1 is equal to R2 and equal to R3, which is the case for transformers, the windings are equal, then the line-to-line resistance, so it's just R1 and parallel with 2 R1, so R2, R3, if they're equal, it's just 2 times R1. And I can do the trick for 2 resistances in parallel. So 2 resistances in parallel is just the multiplication of the 2 resistance divided by the sum. So what this equation is telling me here, let me get the highlighter back. So the line-to-line resistance in a delta is 2/3 of the phase resistance. So line-to-line resistance and delta winding is 2/3 of the winding resistance. So let's do an example. We have a three-phase transformer with a winding resistance of 3 ohms. So the phase-to-phase resistance is 2/3 times 3, which is just 2 ohms. Thank you and have a great day.